Welcome to yet another lecture in algebra, okay? So today we're going to be solving a few basic problems. So I want you to truly understand how these problems work without memorizing anything, okay? Memorization is bad, okay? In fact, it's so bad that I will write it in green right here. Okay, if you memorize, that's bad. Okay, we're going to go ahead and get started with the first problem, which is as follows. Okay. So this is problem number 1. So 5 over 8 minus 3 over 5 is equal to n over 10. Okay, how do we solve this problem? First of all, what are we even supposed to solve for? Okay, what are we supposed to solve for? We're supposed to solve for the letter n. How do we solve for a letter? Okay, well, it's pretty easy. You see 8 and 5, so we're going to need a common denominator. So how do we get a common denominator, you might ask? Well, what number does both 8 and 5 go into? That's a great question, and as a matter of fact, I'll answer it by writing it as such. We call it LCD. We call it least common denominator. So the least common denominator of 8 and 5 is what? Guess. I'll give you the answer in 3, 2, 1. It's 40. Good job, you guessed right. It's 40. Now what we're gonna do is rewrite this crap in terms of 40. So let's go ahead and do that. Now, instead of 8 here, we have 40 here. Since 40 is 5 times 8, whatever we have here has to be 5 times whatever was there before. Okay, so let me put it like this. Yikes, let's make it nicer. So before I had 5 over 8, but now I want 40 at the bottom. So how am I going to get 40? I'll multiply by 5 at the bottom and 5 at the top. I'm going to do the same thing for the other fraction. The other fraction was 3 over 5. And now I'm going to ask you, viewer, what am I going to multiply this fraction on the top and bottom by? I'll give you the answer in 3, 2, 1. That's right, it's 8. Good job, you guessed right. And why do I multiply by 8 on the top and bottom? So that I can get the LCD of 40. So 5 times 5 is 25 over 40. Minus 3 times 8 is 24 over 40. Now, don't forget about the other side. We still have our right hand side over here, and that's n over 10, right? N over 10. But that's not in the common denominator either. We want all the bottoms to be 40, not just 1 or 2 of them. We want all of them to be 40. So, what do we have to multiply this fraction on the top and bottom by to get 40? I'll give you the answer in 3, 2, 1. That's right, it's 4. Good job. So multiply it by 4 on the top and 4 on the bottom so that it becomes, so it's going to become what? It's going to become 25 over 40 minus 24 over 40 equals, now here's where it gets a bit tricky. What's 4 times n? It's just 4n, right? Hopefully that wasn't too hard. And what's 10 times 4? Well, I'll give you the answer in 3, 2, 1. That's right, 40. 10 times 4 is 40. Now, we can just subtract like normal. 25 minus 24 is 1. And we keep the bottom the same, 40. And that's equal to 4n over 40. Now we do something called cross multiply. So what we're going to do is multiply 1 times 40, and we're going to write it down on the left hand side. 1 times 40 is equal to, and now we're going to multiply 40 and 4n, and we'll write that on the right hand side. 40 times 4n. 1 times 40 is 40. 40 times 4 is 160. But don't forget the variable, and now we can just divide both sides by 160. Now we can just cancel out. 160 over 160 is just 1. 40 over 160, the zeros cancel out, and 4 goes into 16 4 times. So that means our final answer is n equals 1 over 4. So I'll write that in blue here. N equals 1 over 4. Let's write that again very nicely. N is equal to 1 over 4. Now we're going to move on to the next problem. Okay, I think there's a few hundred problems, but clearly, since you're already watching the video, you know how long it is. So you can skip through and cut the suspense, but I encourage you not to do that. Okay, so as I'm erasing the board, I just want you to think about what problem will I put on the board next. Let's see if you can predict. Okay, have you made your prediction? Let's see. Here's our next problem. N, let's write it big. N plus 8 over n equals 16, or rather 6. Let's change up the problem a bit. Now, how do we do this? Well, it's as easy as pi, okay? And what do I mean by that? Well, I'm going to multiply both sides by n. Why do I do that? Because here's a fraction that has a bottom of n. If I multiply both sides by n, watch what happens, okay? So, I'll have n times some crap is equal to n times some crap, okay? So, I'll have on the left hand side n plus 8 over n, and on the right hand side I'll just have 6. So what are we going to do right now? We're going to use a property called the distributive property. Okay, n times n is simply n squared, plus n times 8 over n is just 8, is equal to n times 6 is just 6n. Hey, that's just a quadratic. I can now bring all the n's to one side, and now I can solve for n. Now what I have to do is find two numbers that add to negative 6 and multiply to 8. So I can write that like this. Something plus something equals negative 6, and something times something equals 8. So I have to find two somethings that when I add them together I get negative 6, and multiply them together I get 8. What are those two somethings? Well, what about 2 and minus 4? 2 minus 4, 2 minus 4. Let's see if they work. 2 minus 4, is it equal to negative 6? No, it's not. It's actually equal to negative 2. But we don't want negative 2. So 2 and negative 4 don't work. So we have to try something else. Negative 6. How about another two numbers? What about negative 2 and negative 4? Well, good job. These two actually work. Is negative 2, negative 4, negative 6? Yes. Is negative 2 times negative 4 negative 8? Sorry, positive 8? Yes. Okay, so now all I have to do is factor this out. So n minus, here's one of the numbers I have, negative 2. Here's another number I have, negative 4. Okay, so and that's equal to 0. Okay, so what does that mean? Well, if I distribute all of this out, I will get all of this. So I should have put negative 2 in there, and I should have put negative 4 in there. And if I fold this out, you'll see I get this back. So my final answer is that n is equal to positive 2 and n is equal to 4. Okay, and of course you can go ahead and check that out. If I plug in 2 here, I'll get 2 plus 4, which is indeed equal to 6. So that's your answer for that question. Let's move on to the next question. Question number 3. Once again, as I erase the dry erase board, I encourage you to think about what my next problem may be, and go ahead and see if you guessed it right. Okay, now here's our next problem. N plus 3 over n minus 3 is equal to 12 over 3. The first thing you should notice is that 3 goes into 12. So instead of writing 12 over 3, I can just write 4. And hey, now I can just go ahead and cross multiply, because that right there is a fraction, right? So I can cross multiply and get what? 4 times n minus 3. So 4 times n minus 3 is equal to 1 times n plus 3. And 1 times anything is, of course, itself, right? So now I can distribute 4n minus 12 is equal to n plus 3. Now I can bring all the n's to one side, so minus n, these n's cancel out. I'm left with 3n minus 12 equals 3. Now, of course, I can add 12 to both sides. Hopefully you can see this low down on the board. And I'm left with 3n is equal to 15. Okay? And if 3n is equal to 15, I have only one step left. Divide both sides by 3. And what do I get? I get n is equal to 5. Okay? N is equal to 5. Hopefully you were able to see that in action. Now we're going to move on to the next problem. Hopefully the final problem, but of course not. Let's just erase all of this. So as I erase the board, I encourage you to think about what my next problem might be. Okay, so this should actually be problem number 4. I forgot to change the ticker. Okay, so our next problem is as follows. 9 over n is equal to n over 4. How do we solve this? Well, this one's actually pretty easy. Once again, I'm going to cross multiply, right? N times n is going to give me n squared. 9 times 4 is going to give me 36. And of course, now I know that if I square root both sides, what am I going to get? Square and square root cancel out. I get n is equal to plus minus 6. Okay? Let's move on to the next question, which is hopefully a tad bit easier. Okay, a tad bit easier. And this is our next question. Here's our next question, and here it is. I have 4 over n minus 3, which is going to be equal to 9 over n plus 2. Now the name of the game when it comes to these questions is once again cross multiplication. So I'll have 4 times n plus 2 is equal to 9 times n minus 3, right? I can take the distributive of both sides, so 4n plus 8, if I multiply this and go ahead, and 9n minus 27. Now all I have to do is isolate n, so bring all the n's to one side. So 5n is equal to 35, and so n is equal to 7. Okay? Now let's move on to our final problem, which may be a tad bit difficult, a bit of a challenge, but hopefully you are up to a challenge by now. If you've gotten this far, then surely you are. So let's write it down. Problem number 6, if I do believe correctly, if I do remember correctly. So I'll have x plus 2 over 3 plus 4, and why don't we spice it up a bit by changing the x to an n, and that'll be equal to n plus 9 over 2. Now, how do we solve this problem? Well, this might look a bit weird, but what I'm going to do is multiply both sides by a number. Can you guess what that number is? I'll give you a few seconds. Okay, it's going to be 6. I'm going to multiply both sides by 6. Why? Well, look what happens. Watch what happens. So I'm just rewriting everything that's inside. This is equal to 6 times n plus 9 over 2. Now watch. 6 times this will just give me 2 times whatever's on the top. Plus 6 times 4, which is 24. And 2 goes into 6 3 times. So I'll be left with 3 times 9 plus n plus 9. And then I just distribute this. So 2n plus 4 plus 24 is equal to, I'm just going to distribute the right hand side, so 3n plus 27. And now I'm just going to isolate the n. So I'll subtract 2n from both sides. So I get n is equal to, well, this is 28 and this is 27. So if I subtract from both sides, I'll get that n is equal to -1. Okay, folks?
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.